Hi everyone, I am Dr. Surjit Singh. We will now discuss the Leetcode problem 3 sum. Nums is an integer array in which the numbers can have a repeated occurrence. The numbers can be positive, negative or 0. We have to find all the triplets for which sum is 0. The order of numbers in the triplets is immaterial. Same triplet must not be present more than once in the output. The size of the given array can be up to 3000. Since the output cannot have duplicate triplets, the processing will become easier if the list is sorted, so that we can handle the repeated entries easily. Consider the given list called nums. We will find the triplets and store them in the output variable. Output list is empty to begin with. First step is to sort this list. Sorting gives the modified list which is shown here. Time complexity of the good sorting methods is of the order of n log n, which is negligible compared to the overall complexity of 3 sum, which is n squared. We loop over all the numbers. For each number, we will follow the 2 sum approach on the remaining list, for which the target will be fixed such that the sum of the 3 numbers is 0. When -8 is the pivot number, target for remaining 2 numbers is set as +8. 3, 5 and 4, 4 are 2 such pairs in the remaining list, and in both the cases, sum of the triplet is 0. After -8, we process the remaining numbers sequentially. During these iterations, when the positive number 2 becomes the pivot, its sum with the remaining numbers cannot be 0. Hence, there is no use going further and the process will be stopped. So, we put this check. If pivot is a positive number, we break the loop. -7 occurs twice. Its second occurrence will give same triplets as the first. So, multiple occurrences of any pivot will be skipped. This check is easy because the list is sorted and the equal values are present adjacent to each other. This if statement takes care of that. The pivot should be processed only if it is either at the beginning or of the list or if it is not a repetition of the previous number. The skeleton is now ready for calling the 2 sum function. We will pass nums the pivot position I and the output list to which the results will be appended to the 2 sum function. 2 sum function will scan list nums from I plus 1 onwards. First approach for 2 sum is using hashing. In the 2 sum function, a hash set is defined to keep track of numbers already processed. As we do not need the indices of the numbers this time, we do not need a dictionary. We set up a loop over j which runs over the remaining of the list. This means that j takes all the values from I plus 1 onwards. After processing every number, we add it to the hash set before processing the next number. Now that the 2 numbers are fixed at positions I and j, we define a third number called complement, which is the negative of the sum of these 2 numbers. If the complement is present in the hash set, it means that the number was encountered earlier in the list and a triplet has been found, and we save the triplet in the output list. After saving the triplet, we will skip all subsequent numbers that are equal to it because they will give us the same triplet. So we will check that as long as the list is present and the next number in the loop over j is same as the current number, it will be skipped by increasing j. Before moving to the next number in the list, the current number at j is added to the set to keep a record of all the processed numbers. Lastly, we increment j and shift the index to the next number in the list. When the loop over j ends, all the triplets involving the current pivot have been found and the focus now shifts back to the main program. Let us now discuss the time complexity. In 2 sum function, For every value of j, the number is processed only once. So its time complexity is of the order of n. This function is called n times by the main function, so the overall time complexity of the program is of the order of n square. The sorting time is of the order of n log n, which is negligible compared to n square. So the overall time complexity is big O of n square. Let us now discuss the space complexity. Had repetition been allowed, the worst case space complexity of the output would have been of the order of nq, that is, when the entire list is of zeros. However, as repetition is not allowed, the worst case space complexity is much less. Actual size of output will depend on the input values. It can be proved mathematically that the maximum space complexity of the output is not more than n square. Let us now discuss the space complexity of the working memory. If in-place sorting is used, extra space for sorting is of the order of log n, otherwise it is of the order of n. And this sorting memory is released before the main loop starts. Main function uses a few constant memory locations. Second function uses a hash set. The maximum size of the hash set is n, so the overall space complexity is big O of n. As the input list is sorted, the function toSum can also use the two-pointer method. For this method, the main function is the same. For toSum function, we set two pointers, namely low at I plus 1 and high at the end of the list nums, and run a loop while low is less than high. We will move the pointers low and high such that the sum of the pivot number present at position I together with the numbers present at positions low and high become equal to 0. So we compute the sum. If this sum is less than 0, we will increase the pointer low. Since the list is in ascending order, increasing low will increase the sum, while if the sum is greater than 0, we will decrease the pointer high, which will decrease the sum, and if it is neither of the two, the sum must be 0, which is saved to the output. As multiple solutions are possible, we shift both the pointers to search for the next solution for the same pivot. Now we have to skip all repetitions of the current output like we did in the previous method. For this purpose, we keep on increasing low as long as it is not the end of the loop and the new number is same as the previous number. When all the while loops are over, all the triplets have been added to the output list. Let us now discuss the time complexity. The two pointers, low and high, move towards each other and together they will scan the numbers of the given array once. So two pointer has time complexity of n, and this function is called once for each number in the given array. Clearly the overall time complexity is once again n squared. The space complexity for working memory is of the order of 1 for this method, as the numbers are not saved after they are processed. Now we consider a variation of the three-sum problem in which sorting is not allowed. There is no improvement in either time or space complexity. Let us look at the solution. Consider the same list again. Output is a set which is empty in the beginning. We will add triplets such that 5, 3, minus 8 to 8, for which sum is 0, and the output will contain all such triplets with no repetitions. We run a loop over nums, turn by turn, each number becomes pivot. In the first iteration, 5 at index 0 becomes pivot. In the subsequent steps, list members after the pivot number 5 are processed and we find two triplets that are added to the output set. Next, 4 becomes pivot, which gives two more triplets from the numbers present after this pivot number. These are also added to the output. When pivot is another 5, it will give the same two triplets which are already found during the processing of the first occurrence of 5 at index 0. So we don't need to process the repeat occurrence of 5. For this, we use another set called processed that will save all the pivot numbers that are already processed in this for loop. The new pivot will be processed only if it is not present in the processed set. This will save execution time in case of duplicates. Let us now discuss the details of the processing of the list. The first pivot number is 5. This means that for the remaining list, the target is -5. With target as -5, we can call toSum on the remaining list and find all pairs from the remaining list for which sum is -5. As the list is not sorted, two-pointer method cannot be used, so we use the hashing method. We need to process all the numbers after the pivot. So the second loop starts from index I plus 1 and value at I plus 1 is stored in val2. Every number that is processed in this loop will be required for future reference. Therefore, we define a set called scene at the start of this loop, and every number is saved in this set in the last statement of the for loop. Third number has to be negative of sum of val1 and val2. We call it complement. If complement is present in the set scene, it means that it was present in the list scanned earlier. So a triplet has been found, which is saved in the output set. It may be noted that triplet 5, 3, minus 8 obtained when number 5 was the pivot is same as 3, 5, minus 8 obtained when 3 is the pivot. So we sort the triplet before adding it to the output set. A set cannot save duplicates, so both of these will be saved once only as a tuple in the sorted order, that is -8, 3, 5. This brings us to the end of the program. For detail on hashing, please refer to my video on toSum using hash. Time complexity is again of the order of n square because there is a loop over n within another loop over n. Space complexity of working memory is of the order of n, used by the hash sets in which processed or scene values are stored. Let us discuss the space complexity of output. In the worst case, there could be of the order of n square distinct triplets. Thanks for watching the video. Please stay tuned.